Great, folks. Thanks for showing up at the new spot. Thanks again to Great Bay Community College for giving us. We're going to seriously be able to fill this place up now. Things were getting a little bit cramped and tight over at Green Pages. So when Great Bay said that they would sponsor us, this was a pretty cool win for us. We actually got a couple of new sponsors, so we should. So the one downside, no beer. There's no alcohol allowed on campus here, so that's one of the cons. One of the pros, a lot more space, a couple more sponsors, so we should be in pizza for the foreseeable future. So with that, I met Kunal at the VTUG Winter Warmer in January, and he and Robert Zhu, who you'll be meeting soon when he gives another presentation, and Randall Hunt were up there doing the AWS post reInvent, all the services in 50 minutes or less, speed talk. and I met up with Kunal, and I hit him up for this, and he graciously accepted to come on. And then he said, hey, how about a sneak preview for DeepRacer? So with the DeepRacer League that we're going to be kicking off, I figured that would be a perfect segue into having you give us a little bit of, excuse me, pizza breath. Thank you, sir. Appreciate it.
Of course. All right, guys, let's get started. So my name is Kunal Batra. I am a senior developer, technical evangelist at Amazon Web Services. Just a quick show of hands. How many people here are using any of Amazon Web Services in production or just learning right now? Awesome. All right. So for this talk today, we're going to be talking a little bit about the DeepRacer. And here's a breakdown of the agenda. Kind of go into the DeepRacer, talk about the origin, why we created it, a little bit about machine learning, AI, reinforcement learning to give a background of what powers the DeepRacer. We'll go into the console just to see how you can create your own model. And at the end, we'll talk a little bit about what's actually under the hood for the hardware of the DeepRacer car. Can everyone hear me okay? All right, perfect. Let me know if you can. So for the origin of the DeepRacer, how many people here have actually seen the Deep Lens before? All right, nice, a couple. So with the Deep Lens, back in 2017, we introduced a new service called AWS SageMaker, which was our service for developers to help them build and deploy machine learning models at scale. And we really wanted the ability for developers to actually test this out in the real world, and not just be an algorithm in the cloud. So we built this Deep Lens, which is a camera, and it's actually on top of a computer, so you can deploy the models that you train in the cloud to this device, and then actually see things and how they happen in motion, like classification or object detection or image semantic segmentation. It's really cool to see. I wish I brought my Deep Lens to show you the demo of that. And then in 2018, when we introduced reinforcement learning, we're like, how do we get this in the hands of developers? So we had this great idea to create this autonomous self-driving car. I think it says 1/18th the size of an actual car. I don't know how they measure that, but that's awesome. And then two other things. A virtual simulator, so you can actually train your DeepRacer models in the cloud, as well as a DeepRacer League, so developers can compete against each other globally and see who has the fastest model, and hence the fastest car. And so just a little bit before we get into the car and the service, I just want to talk about a little AI, machine learning, and reinforcement learning. And just to get an idea of the crowd, how many people here are familiar with just artificial intelligence in general? I can describe it like in a sentence. Oh, my hands go down.
Everybody's up. Oh, wait, that's your job.
Yeah, I know. I'm going to see if I can.
Get some sucker there.
So artificial intelligence, really quickly, is any sort of code or system that lets you mimic human behavior. And this doesn't have to be anything super smart or sophisticated. This can be a bunch of if or else statements that can mimic how a human might interact with a certain system. Machine learning then goes into one level below that, where it's actually learning, and it's not explicitly being programmed to learn or do a certain action. And then once you get subsets underneath that, you have three more that are listed here. Supervised learning. So for example, I'm sure everyone here is familiar with Hot Dog, Not Hot Dog, the viral AI app. Well, to build something like that, you need a bunch of labeled data. you need a bunch of images of labeled where someone says this is a hot dog, and another bunch of images saying this is not a hot dog, and then you train a convolutional neural net to build that, and now you can take a photo of any hot dog, even if you haven't seen it before, and tell you this is a hot dog or not. That's supervised learning, so it needs a lot of label data. Unsupervised learning is no label data. You just give a bunch of inputs to a model, and then it starts looking at the similarities between that. And then you can do things like clustering, where it knows the differences between different types of data. And then we have reinforcement learning, which is really cool, which is learning from the consequences of actions in a specific environment, kind of like us. And so this car also follows that. And so some popular use cases of reinforcement learning: autonomous cars, fleet logistics, which is making it efficient for delivery or trying to optimize delivery times, financial trading, and then data center cooling and HVAC systems. Kind of the 4 big use cases we see with reinforcement learning. And so in reinforcement learning, the idea is to create a model that gives agents the ability to make an action in a specific environment with a goal. So with the DeepRacer, we have the idea is to build a model so that an agent, in this case the self-driving car, can make an action, or choose to make an action, which is going left, right, backwards, forward, speed fast, speed slower, in a specific environment, which is this track over here, and with the goal of completing that track. And this is kind of what's happening behind the scenes with the DeepRacer. We have this agent, which is the DeepRacer. And by the way, when you're training the DeepRacer, you can't train it in person. You can't train it with a physical car. It has to be trained in the actual console, because it needs to know what's happening in the environment around it. It needs to know whether it's going off track, on track, and it's hard to do that with an actual track. It's easier to do that in the simulated environment, and I'll showcase that a little later. So with deep learning, with reinforcement learning in the DeepRacer, you have the agent, which is the simulated version of the car. It takes actions. And in the beginning, when you're training a new model for the DeepRacer, it doesn't know anything yet. It has total newbie. It was just born. So it's basically taking random actions and just exploring the environment. It's going backwards, forwards, fast, slow. And then every time it makes an action, it checks its state. What have I just done? And then what's the reward for my current state? And so one of the things as a developer, what we do is we create the rewards. So we can make a reward saying, if you're in the center of the track, then you have a high reward function, and when you check your state, you did awesome, keep doing that. If you go too far away, now you have a very low reward, that's not as good. And so with the AWS DeepRacer, one of the main things we do is create that reward function. I'll walk you guys through that afterwards. And we keep doing this cycle, and we can choose how many times we do the cycle, and then we learn from it. We learn how we're doing, and then we try to, from there we can improve our performance on the track. Does anyone have any questions so far? Yeah, go ahead.
So when we're evaluating that state,
Yeah.
we also know about the whole track. Is that true?
Yeah, so we have information on the environment of the whole track and what's going on. So we know this is the actual track. It looks just like this. So we know this is the goal. We know what our progress is so far. We know certain things like here's our car, here are certain points, how far away from these certain waypoints, what we call it. We know the position. And also every time the car goes off track, we shut off that simulation and we restart it again. Because there's no point for the car going off track. We want to make sure that people choose the right reward functions where it just kind of completes the track. Did I answer your question?
Yeah. No, I was curious about sometimes being in the center might not be the fastest, right?
Right. It might not be the fastest. You might actually want to create a reward function that says when you're getting closer to the curves or faster to the curves, you want to go closer to the not in the center.
Thanks.
Yeah.
Excuse me.
Yeah, go for it.
Are there any environmental factors that are considered outside of the track?
So with reinforcement learning, one of the things is it's a specific environment, right? So when you're training it, it's trained just on that environment. But in real life, when you deploy that model you create in the simulated environment to the car, and now you're doing it in the real life scenario, a lot of things that are not variables that come into play, like lighting. Is the lighting for the track visible? If the track's not visible, then the car's not going to know what's going on, right? The other thing to note is for the DeepRacer, when it's actually checking its state, it takes a photo 10 times a second, and every single time it takes a photo, that's when it checks how am I doing, and what's the state, what's the reward function, and that's how it works.
So is that a deep lens on that?
That's actually a deep lens. I noticed that too. No one told me that this is a deep lens. I noticed it's the same exact thing, a deep lens.
It's like one that's,
I don't know if you guys can see it from there, but we actually have on the car a couple of extra USB ports. So the deep lens is plugged into the center one. And then you have 2 additional ports here and another USB port over here. And that's meant for, in the future, if a developer wants to add more sensors to the car, you can do that.
Or a Nerf cannon.
Or a Nerf cannon, exactly.
how expensive are these?
Good question. I got mine. How much is it?
$299.
$299?
And how long do they last? Like 10 minutes?
100,000 miles.
Oh, the battery? That's a good question. I think what I read was the battery for the actual RC part of the car lasts 30 minutes. And then there's another battery on top over here for the actual computer. So it's actually a remote control car with the computer on top of it. The computer runs Ubuntu and then Intel OpenVINO to actually make inferences from the camera, what it sees. So there's 2 batteries going on. So the computer might last longer than the actual RC part of the car. Yeah,
You say it takes a picture every 10 seconds or 10 pictures every second?
10 pictures every second.
Okay, cool.
So basically each loop over here, it's doing it 10 times a second. Yeah.
Christ, it looks like they're up to $3.99 now.
It's what's that?
They're up to $3.99 now, not
Wow.
$2.99. I think that was the preview price that,
Oh,
yeah, they went up.
okay. I'm wrong.
Yeah.
So when the car is driving, the only input is from the camera, right? The
Yes.
picture.
Yes, exactly.
And plus probably internal sensors like how
Yeah.
fast I'm going and.
Yeah, so there's 2 other sensors in there, the gyroscope, and then I forget what the other one is, but one more. But it's those 3 items. But mainly the camera is what's the state of the car.
Now, during the training, for those functions, are there any other inputs considered, like somehow taking the entire track course into consideration for those
Yep.
functions?
Yeah, yeah. So the track is considered. Also, we give you a bunch of parameters of the whole environment. So we give you the XYZ coordinates of the car. We give you waypoints of the track, so you can kind of get an idea of where the track is. We give you. I'll walk you through that.
Okay.
I think also maybe traction, is traction a sensor?
Traction is
What happens
not.
when you start to slide, if you're going too fast around that curve, is it
So you can create a reward function saying that, am I going too close from the center? Am I going closer to the center? Optimize for that. So give it more points for being on the curve, maybe not at the center, maybe a little bit closer to the line to prevent that. Awesome. So that was a little background of what we're doing with the car, why we created the car. Now let's get to the fun part, which is creating a model for the car.
I like console time,
Console time.
not command line time?
Well, it's the actual AWS Console. So this is not launched yet. What you're seeing right now is what's going to be available later this month. As soon as you go to the DeepRacer page, this will become active in your, as soon as you log in, you see all those services over there. You'll be able to search for the
It's not
DeepRacer.
GA, right?
What's that?
It's not generally.
It's not generally available yet. So right now you can see the landing page of the DeepRacer. I recommend the first time, if you really want to build your own virtual model in the cloud, definitely read through the landing page. A lot of good information and tips and links for documentation and the developer forum if you have any questions. From there you can go ahead and create a model, which is what we're going to do. Once we build this model, we can do a couple of things. We can deploy it to the car. We can also then evaluate it and kind of enter into the virtual DeepRacer League with our track times. So the first thing we're going to do is model name. Since this is a live demo, I'm going to say please work. The model description over here, just going to call it Smith AWS user group. And so now we chose our model name, gave it a little description so we know what the model is. Next option we get is the environment simulation. So right now we only have one track you can train on. In the future we're going to have a bunch more tracks coming. I'm not sure if these tracks will be at time of GA, but right now it's only one. And then this is the part where we were all kind of discussing before, which is the reward function. And this is where we kind of give the meat on training the car and telling it what we want to optimize for and what we don't. Right away we got this default reward function that has a bunch of comments in here, just kind of going through all the environments that we can, all the parameters we can look at to create a reward function. And if we just skip that on the bottom, you can see that what's not commented is just the code letting us know that here's a reward function, and it's kind of just saying if this car is in the center of the track, that's good, give it a 1. Otherwise, if it gets from the center, it's not in the center lane, or center right on the dotted line, and start giving it a lower and lower reward function. So that's how this particular reward function is set to optimize for. But just if we go back up to see the comments, I just want to give you a little bit of what you can optimize for the model. You can see over here that the first thing we have is the vehicle off track. And you can combine any of these sort of parameters for the reward function. Can you see that? Should I make that bigger? Oh.
Yeah, that's good.
That's good?
Yeah.
Okay, cool. You can see the XY coordinates. That's cool, but not cool by itself. You want to probably combine that with something else. Distance from the center. This is the distance from the center line of the track. Car orientation. Progress, percentage, how far the track has gone, the car's gone on the track. Throttles, makes sense. Steering. Track width is a feature you can define over here. And then the waypoints are points of the track I kind of showed you before that we automatically give to you. And you can compare progress to those waypoints. So this is the basic reward function that you get in the console. You can also go ahead and kind of put in an advanced function over here, and you can insert that in. And this advanced function has not only the track, I think it has some steering as well. So definitely, I think this is the best part of the play around with. So let's go ahead and then just pick the default reward function.
Is that ABS that listed? Is that absolute value or are there analog brakes on that value?
Absolute value, probably, yeah. And then the algorithm settings. So the algorithm settings over here, I tend to use the default ones. These are, if anyone's trained the model on SageMaker before, these are the hyperparameters you can use to say how the model is going to train. But we have info there to kind of go through each one and see if you want to modify that. One of the things that people tend to modify a lot with hyperparameters is this last line over here called episodes. Episodes is how many times does it go through that cycle of each state. And so basically, how many times does it take photos, understand a state, and learn from it. So the more episodes you give, the more data it's going to use to train itself, the more iterations around the track it's going to use to train itself.
So how do you know whether you're not overfitting it?
Well, that's the thing. If you do it too much, now it's going to be overfit, only good for that track. Now when time changes, then it'll take longer to build if you do too much as well.
Check your credit card statement too.
Yeah. One of the things with the question we just got was overfitting. I'm not sure if everyone here is familiar with the term overfitting, but if it is overfit, which means that it gets so good with just that track that if you give it a new track or any new data, it won't work on that. It was just kind of perfectly tuned just for one set of inputs. Next is the stop condition. Stop condition, I don't know why the default here is 60 minutes. I'm sure that's going to change when the service becomes generally available. Normally when it takes around 2 hours to train a reinforcement learning model. So over here, I'm just going to bump this up from 60 to maybe something like 154. You can do less, but it just won't train. So we're going to click Start Training. And
So
it's
if you
training.
choose a higher model, will it go faster?
A higher model or a,
The EC2, you have an ML.
so it's a default EC2, it's instead of fixed over there.
So it is like,
If you want to go outside of the console and kind of do it yourself, you can definitely do a higher level model and then train faster. So now we just have to wait 2 hours, so feel free to, I'm kidding. So it's training right now, it actually will take 2 hours. Oh man, I had another model I wanted to show you how it looks like when it's training. It looks like it just finished. Okay, so basically, when the model is training, it'll actually start going around the simulated track, and you see it's like this 3D track in the 3D world. It's going around this track. Every time it goes off the track, it resets the training and it starts simulating again. It's really cool. So, I thought it'll be running right now. It might take another couple of minutes.
So in regards to the code,
Yeah.
was there any like validation or anything in there? Like I know, with Lambda or something, if you have a syntax error, which kind of pointed out, how do you know before you wait 2 hours that your code is wrong?
It'll tell you right away that the syntax is incorrect.
Okay.
Yeah, and actually, it's working right now, so let me scroll down. So this is happening in real time right now. This is the simulated car going on the simulated track, and it's trying to keep in the center. So this is really early on, and as soon as it gets off track, it resets again the simulation. And from here, it's again trying to be as close to the center of the line. And then after 20 of these iterations, then it'll stop, start training again, and then it'll just reset the simulation and keep going for like about 2 hours until it gets a model that we can use and we can deploy that into a car.
So the steering and the speed is random right now?
Everything's random in the first iteration of it. Yeah. Let me give you another view of this. So this is another view in the virtual world of the track. Let's see the car. I can't seem to find it.
So is this running on CPUs, GPUs?
This particular model is being trained on a CPU, I believe, but I think you can run it on GPUs as well. You definitely run, yeah, there it is right here. So this is the actual track. It's actually falling pretty good to the center line right now.
So when people are racing each other.
This is not the
how do
first
you know
model, by the way, sorry. This is
When
the,
people are racing each other, their multiple cars will show up on the same track?
no, so in this case, when people are, no one's actually racing against each other, you're competing against the times.
Ah, okay, so it's same.
Right, exactly.
And
Yeah.
the DeepRacer League, is that all virtual or actual physical?
Yeah, good question. There's two DeepRacer leagues. I think it's one DeepRacer League, but there's a virtual part of it where you can compete just with your models online, and it kind of see who has the best times for the track. And then there's also in-person racing leagues, and I'm not sure the details of how they're separating each city and like how they're running the events. But from there, I think at the end of that, there's like finals, and then there's like semifinals, and then at the end, there's like one big event, I'm pretty sure. And then from there, so there's two parts of it, virtual and in person. Yeah.
So when can we like bring our own courses so I could like have like Rainbow Road, right?
That's a good question. I don't know. I know that they're working on tracks, but I'm not sure when we can like bring our own tracks. All right, and then let's talk a little bit about the college. I think we're good. Let me just go. Feel free to ask questions if you want to.
So I don't know if you know the answer right now, but would you need to have the physical device if, it's like obviously it looks like what you just did, you don't need the physical device. So if you want to participate in a league, is the physical device a requirement, or is that if you wanted to be in the physical league, or is, like what?
No, there's no requirements. You can actually just train the models in your console, and then when you want to go to the in-person event, there's always going to be extra cars there where you can load up your model.
Oh, awesome.
And then it's interesting. I don't know why it is. When you load up the model, there's a little USB port in the back over here, and it automatically just sees that the model's on there and the USB stick, and it just loads it into the system, and it's able to go. Yeah.
So when you buy this, what level of assembly do you need to put on this, or it comes clear?
It comes like this. This chassis is already on it, and then that's how it just comes ready to go.
Or you don't have to do any assembly and all that?
No, you don't have to do assembly. What you do need to do is put the batteries in.
Or you have to buy batteries extra?
It comes with the battery, but you have to just plug that in, make sure it's charged, and then from there just load up your model and the USB stick over here.
So it comes with a charge and all, you don't have to buy anything extra for it?
Exactly, everything comes with it, yeah. Batteries included.
We can't mod the motors, I'm assuming, right?
With, you can. I mean, there's Ubuntu, which is on the operating system there, so you can log into that and do whatever you need to do to
Good point.
Scarf, yeah.
Skin peel out.
Yeah, exactly.
I'm not sure if you're eligible for the race though.
What?
I won't say anything. I won't say anything.
Only if they're checking.
It's like NASCAR rules, right? Like you gotta have all the aerodynamics have to be the same, right?
Put the air horn on this.
Good idea.
So during the training, it's obviously the simulated the simulated environment
Yeah.
that's being fed to as part of the input to the model, plus the simulated sensors. But how would that then you work in a real world environment? Like, are they building track, like on a physical track? Are the physical tracks with just a plain gray track and a gray box around them?
Yeah, yeah. So right now, when you have the actual physical leagues and you want to use the actual cars, the actual tracks are going to look just like the ones I just showed you.
Okay.
One of the things they are doing when we train it though, they're randomizing kind of the features of the tracks, are randomizing the colors, making sure that kind of the visual inputs it sees is different every time it runs a simulation. So that when it actually gets on any real world like track, it doesn't matter what the colors are of the environment of the box or anything like that. Oh yeah,
You said
this
it was
is
a
the
gyro and something else. It's like
oh, accelerometer, right? Yeah.
So
and-
my question is, if we buy this, can we just use it for our own stuff? Do we have to go through SageMaker and train it? Or can I just directly from my PC?
You can run your own models on it if you want to. You just have to know the exact format of the model that it takes, but yeah,
Okay.
you can actually do that. Nothing's locked down in that sense.
A quick question off
Yeah.
topic. I'm sure AWS's thing, as machine learning becomes smarter in the years to come, do you see like a drone version of this? You know, your autonomous trained drone?
You know, like a deep flyer.
Deep flyer. I know personally that would be awesome. But the way AWS works is if there's a customer demand and someone's asking for it, it'll
I'm out.
So ask for it, ask for it, ask for it.
It'd be
Yeah.
a free competition for package delivery
Yeah.
drones.
Right.
And version 2 will be identify the bad guys and kill them from the air.
Oh man. In this slide, just quickly, you can see that the software that runs on the computer is Ubuntu, so you can feel definitely moddable. It runs Intel OpenVINO, which is doing the inferences that it gets from the camera, and then sending that to the model. It also, I think like you mentioned over here, has accelerometer and gyroscope, and then it has storage on it, right? So it has 32 gigs and it's expandable. Just
So
in
does
case
it have
you want to
Wi-Fi
do it.
also? No.
Yeah, it says it has Wi-Fi, but I haven't been able to access mine. Yeah, maybe it's locked down for my version of it.
So this is like 10 frames a second. I assume that a lot of that's spent like in the inference, right? Like taking the pictures fast, right? Like just taking a photo. Since that's running like OpenVINO, can I like put in like the Intel like neural compute stick in one of my USB slots and like speed that up?
I've heard people talking about that too, just kind of put it over here. I think there was a reason why it was designed like this too, to put that USB stick
Yeah.
in this fashion over here, so it doesn't stick out, but it can actually be in the thing, and you can still have the chassis over it. I believe that might be possible. Yeah.
Do you know if like the kind of gold image of the OS will be publicly available so that when I go in there and mess it up while I'm tinkering, I can revert? Is that-
I'm not sure.
All right.
Yeah, I'm not sure.
Definitely need that.
Well, it's anything like the deep blend, right? Like they had this universal reset thing that you could push if you like bork the image that would just reset factory.
Yeah, I think we have this over here as well.
Yeah.
And then on the bottom of each car, it's specific to the thing, but has all like the information for the operating system as well. So you can go ahead and access that whenever you get your car too.
You didn't mind Bitcoins?
Not yet. Nice. Any other questions, guys?
How fast can it go?
That's a good question. I don't know the specific number, but when I saw it at an event, it was pretty fast.
You could run it, keep up,
What's that?
you ran against it, you could outrun it.
Oh, so it wasn't like going in a straight line, it was going in the track.
Oh,
But
okay.
yeah, it was
Is
going
it-
pretty
is it
fast.
enough to like go
But-
sliding when then?
So does it have enough torque that it
Because
goes up
you-
or
It doesn't, so when it went fully, it didn't go up like that. I think there's enough weight on it where it just doesn't do it. But feel free to like pass this around, guys, if you want to get a closer look on it. Yeah, it's got a little weight to it. There's two things, a computer as well as the actual.
So what are these things on the side here?
Good question, let me just showcase it.
Billing and time,
So we just got a question over here. What are these little pins? Basically, the car is actually three things. It's the RC unit, it's the computer, and then it's that chassis over there. So basically, these pins let you separate each layer of the car.
Here's my real world.
Two-wheel drive, four-wheel drive?
Yeah, I think.
I am not sure. I think it's two things.
What's that?
The best start.
It looks like mostly front-wheel drive.
That might be a good starting point. This thing would be a little solid.
Awesome, guys. Any other questions on the car?
Yeah.
This is really cool.
But that concept should be pretty doable, you know?
What do we put in
This
here?
is
It's a battery.
So this is like battery for the Jeep, or?
So the first one's the battery for the computer, which powers most of the deep lens. Bottom one then is the battery for the actual RC car.
If it's just spinning, then it comes in.
Yeah.
The motor.
And that might be more difficult for like simulation.
Let me switch back to the simulation.
Do you know what's involved in constructing a track, a physical track?
It's not much. Basically, it's just the track layout that I showed you before. I showed you
How
the
big
track.
is it physically?
How what?
The physical track?
So waypoints
How big is
waypoints,
it?
there's a 2 or 3.
I don't know if
That's
there is
why
a certain. I know the dimensions. But it's fairly big. For example, as I saw.
think so. So that's all it is. There's no angle. Oh no, there's gotta be a vector in there.
Yeah.
Yeah,
No,
so,
that's why you don't-
in all of the environment, you said, oh, the environment's constant. What about the concept of other cars on the track? Is that something that this, is part of this is
Already
environment
answered it.
Yeah. So not yet. Right now, it's one car.
on the track at a time?
Yeah, it's not looking at. I mean, right now it's not there.
Okay.
Wouldn't be surprised what happens in the future. Awesome, guys. Well, feel free to take a look at the car. Come up to me if you have any questions on this or other AWS services you might have a question about, and about it in any way. Thanks, guys.